everybody, and welcome to the North Manchester STEM Sharing Network YouTube channel. Today we are going to work on our prediction skills. Okay, so today we have a few experiments for you. I will be demoing them. You just need to pause when I say to pause and work on prediction. My 3 top tips for prediction when it comes to a science experiment are: 1. What do you already know about the situation or the materials? Have you experienced anything similar in your life, or have you observed something like this before? 2. What do you know about the properties of the materials involved? Think about what you know about dissolving, freezing, melting, separating, all of these kinds of processes. If you know something about a material, you might be able to predict how it behaves in a different situation. And number 3, stick with what you know happens in the real world. Don't be thinking about films, don't be thinking about sci-fi or comics. Think about what happens in the real world, and that will help you make a sensible, realistic prediction. The first experiment I'm going to show you involves water, gravity, and other forces that act on water. So here I have a glass, and it is half filled with water. There's nothing special about this water, it's just from the tap, and it is tap temperature, so quite cold. And then here I have a coaster. It's made out of cardboard of some sort. There's nothing special about this either. So what we're going to do is we're going to put the coaster on top of the glass. I'm going to turn the glass upside down. You can see that gravity has acted on the water, and I'm going to tell you to predict what happens when I take my left hand away. Pause if you need to discuss or think or write something down. Okay, have you made a prediction? Did you think about what you've experienced previously in your life? Did you think about what you know about water, about glass, about cardboard? Did you think about what you know that happens in the real world? Fantastic, those are my 3 tips. Okay, we're ready. Fantastic, so the water is not falling. The cardboard coaster is being held in place. There are no magnets. There is no glue. How is this coaster acting against gravity? What happens? So, when we turn it upside down, what we've got is the same amount of water inside. We've got the same amount of air inside, and the glass can't change shape. So the glass can't invite any more air or any more water in or out, because there is a seal around the bottom where the coaster is. Because of that, to keep its shape, the same amount of air and the same amount of water will stay in, effectively sucking this coaster to the glass. So the pressure, the amount of stuff inside and how it wants to stay the same inside the glass, keeping that coaster sucked to the bottom, is greater than gravity acting on it, and that's why this seems to be floating and magic and not making a mess. The next experiment I'm going to show you is all about dissolving. We need water, again, just normal water, nothing in it, and we're going to use a spoon to try and dissolve some solids inside. So my first one is salt. Salt. I'm going to tip this into the water, and you are going to pause and predict, is it going to dissolve? Think about the experiences you already have with salt and water, and let that form your prediction. Ready? And there we have it. No more crystal salt inside there, just one liquid. We call this salt water. So an experience from your life that might have helped you make that correct prediction would be the sea. The sea is salt water, isn't it? It's salt dissolved in water. Fantastic. The next substance we're going to see if it dissolves in water is sugar. So I'm going to do the exact same thing. I've taken water from the tap, and I'm going to take my spoon. When we put the sugar into the water, do you think it's going to dissolve? Think about your experiences. Pause and predict. Okay. Remember that stirring speeds up the rate of dissolving. And there we have it. There are no more sugar crystals left in the bottom of the glass, and we have a solution that we would call sugar water. Did your experiences from your life already help you predict this correctly? How about if you've ever made a hot drink, coffee or tea, say, and you've put sugar into that? Our next substance is flour. Flour we use for baking, and it comes in a powder. A powder means that it can steep like this and almost hold its shape. Pause and predict. Okay, I'm putting the spoonful of flour in. Let's get stirring. Remember, stirring speeds up the rate of dissolving. So while the water has changed colour because of small parts of the flour dissolving, it's actually not able to fully dissolve. We are still left with separate parts. We're left with this cloudy water and bits of flour. Were you correct? The next solid we're going to test is sand. This is black sand, which you can get on beaches of volcanic islands, just like the Canary Islands. Okay, pause and predict. Okay, let's go. Remember, stirring speeds up the rate of dissolving. Again, the water has gone cloudy, probably due to some things in the sand that do dissolve. However, the sand itself settles at the bottom. None of it really dissolving. Did you use your experience of sand and water to predict correctly? Think about when you're on a beach and the tide comes in, the water doesn't dissolve the sand and disappear the beach, does it? Fantastic. For this next experiment, we're going to look at what happens when two liquids meet, if they mix or they stay separate. I have two containers here, identical in size and shape. To one, I'm going to add water. I'm going to dye it red so it's easy to see on camera. To my other container, I'm going to add oil. I brought you down to eye level so you can see these liquids from the side. We're going to take a piece of plastic, place it over the water, and we're going to carefully turn it upside down and put it onto the oil. And then we're going to watch what happens. So I'm just going to move things very slowly. Okay, now we're going to watch. Look at the colour difference between the oil, which is yellow, and the water, which has been dyed red. And I'm going to try my best to remove the plastic slowly, keeping the two containers exactly above one another. Here is the closest edge where the substances will meet. Can you see? So now we've got oil on the top and the water on the bottom. So the liquids are absolutely touching each other. And remember how the oil was on the bottom and now it's on the top. Did you predict this correctly? The reason for this is because oil is less dense than water, which means that it floats on the top and it won't mix. I hope you've enjoyed these experiments today and that you've developed your skill of prediction. I'll see you again next time.